Learn like a pro.
All right, let's dive right in. Everything around us, I mean everything you can see, touch, or even breathe, it's all built from the same fundamental stuff. Today, we're going to peel back the layers and look at the absolute foundation of chemistry, how matter organizes itself into what we call elements, compounds, and mixtures. Getting a grip on these categories is really the first big step to understanding our entire world on a molecular level. So, let's start with a little thought experiment. Think about the air that's filling your lungs right now, and then picture a simple stainless steel fork. I mean, on the surface, they couldn't be more different, right? One is this invisible gas, and the other is a hard, solid object. But chemically speaking, they actually share a really deep connection. And that connection is that they're both, of course, forms of matter. But, and this is the important part, they're classified in totally different ways based on what they're made of. Understanding this classification system is absolutely key. So today, we're breaking down these three primary forms: elements, compounds, and mixtures. We're going to start with the most basic category of all, the element. This is matter in its purest, simplest form. The easiest way to think about elements is to picture them as unique Lego bricks. You've got your red bricks, your blue bricks, your yellow bricks. The periodic table is just our catalog of all 118 different types of these bricks. So an iron atom is one type of brick, a gold atom is another. And here's the crucial part. You can't break an element down into anything simpler using chemistry. It's the end of the line. It is the fundamental unit. And what's just fascinating is how few of these elemental building blocks it takes to build, well, everything. Just look at this chart. Oxygen, just one element, makes up almost half of the Earth's crust by mass. And get this, it's an incredible 65% of your own body. It's just a powerful reminder that all the amazing diversity in our world comes from combining just a few key elements in new and exciting ways. Okay, so we can sort these elements into two big groups based on their properties. First, you have your metals, things like copper and iron. You know the drill. They're usually shiny, they're fantastic at conducting heat and electricity, and you can bend them. On the other side, you've got the nonmetals, like sulfur or oxygen. These guys are pretty much the opposite. They're generally dull-looking, brittle, and they act as insulators instead of conductors. Now, here's a cool detail. Elements don't always float around as single, lonely atoms. Some do, like helium, which is what we call monoatomic. But others, like the hydrogen and oxygen gas in our atmosphere, they naturally pair up. They bond with themselves to form these two-atom molecules or diatomic molecules. And some, like sulfur, can even form these big 8-atom rings. But they're all still pure elements because they're all made of only one type of atom. So that covers elements. Now, what happens when we take different types of those elemental Lego bricks and chemically snap them together? Well, that's when we enter the world of compounds. The two words you have to burn into your brain for a compound are chemically combined. This isn't just a casual mix-up, a real chemical reaction has happened here. New bonds have formed, creating a totally new substance. And on top of that, this combination always happens in a fixed ratio. That's a huge defining feature. And this table just illustrates that point perfectly. Look at this. You start with gray, magnetic iron, and bright yellow, non-magnetic sulfur. When you make them react, you don't just get some grayish yellow powder. No way. You get iron-iron sulfide, a brand new, black, non-magnetic solid with its very own unique melting point. It is a completely new substance with a personality all its own, totally different from its parents. This fixed ratio idea is so fundamental to chemistry, it's actually a law, the law of definite proportions. It's like a strict recipe that can't be changed. Every single water molecule in the entire universe is made of 2 hydrogen atoms and 1 oxygen atom. Every bit of table salt is 1 sodium to 1 chlorine. If you change that ratio, you don't have that compound anymore, period. Okay, so elements are these single bricks. Compounds are different bricks chemically snapped together. So what do you call it when you just toss a bunch of different bricks, or even some of those pre-built compound structures, into the same bucket without them actually bonding? That's a mixture. In a mixture, all the parts are just physically jumbled up, not chemically locked together. They're just sharing the same space. No chemical reaction has happened, which means every single substance in there keeps its original identity and its original properties. Think of a salad. The lettuce is still lettuce, the tomato is still tomato, they're just in the same bowl. Air is probably the most perfect example of a mixture. It's mostly nitrogen and oxygen gas, with a little argon, some carbon dioxide, and a bunch of other stuff all mixed in. And we know it's a mixture because its composition can change. I mean, look at this slide. The air you breathe in has a different amount of oxygen and CO2 than the air you breathe out. A compound could never do that. Its ratio is fixed, remember? And mixtures are absolutely everywhere. That brass doorknob? That's a solid mixture of two metals, copper and zinc, called an alloy. The salt water in the ocean? That's a solid mixed in a liquid. And that can of soda? That's a gas, carbon dioxide, dissolved in a liquid. You're interacting with mixtures all day long. So these fundamental differences between compounds and mixtures, they have a huge impact on how we can take them apart and figure out what they are in the lab. So let's take a look at those methods. So here's the core idea. Because the bits and pieces in a mixture aren't chemically stuck together, you can separate them using physical methods, like just filtering them out. But for compounds, you have to actually break those strong chemical bonds. That takes energy. We often use electricity in a process called electrolysis, which is powerful enough to, say, rip a water molecule back apart into hydrogen and oxygen gas. Another really handy test is to just look at their melting and boiling points. A pure substance, whether it's an element or a compound, has a very sharp, specific temperature where it melts or boils. Pure water always boils at 100 degrees Celsius at sea level. But a mixture, like salt water, it boils over a range of temperatures. That little effect is a classic lab test we use to check for purity. All right, we have now covered the 3 fundamental ways we classify matter. So let's do a really quick recap, and then we'll test your new knowledge with a couple of quiz questions. This slide is your cheat sheet. It puts the 2 trickiest categories, compounds and mixtures, right next to each other. If you can just remember these 3 key differences, you'll be golden. First, how do you separate them? Second, is their composition fixed or does it vary? And third, do they have totally new properties or do they keep their old ones? First one up, the ordinary table salt you put on your food. What do you think? Element, compound, or mixture? Yes, absolutely. It's a compound. It's made of 2 different elements, sodium and chlorine. They are chemically bonded, and that ratio is always a perfect 1-to-1. Plus, think about it. Its properties are nothing like the crazy reactive metal and poisonous gas that it's made from. Okay, next one. A simple copper wire, like the kind inside your phone charger. What is it? Element, compound, or mixture? That's right, it's an element. If you could zoom all the way in, the only thing you'd see are copper atoms and more copper atoms. It's a pure substance, and you can't break it down any further with chemistry. And with that, I'm going to leave you with a final challenge. Once you start looking at the world through this chemical lens, it really changes how you see things. So look at the stuff around you, the milk in the fridge, the steel in a skyscraper, the ink in a pen. Start asking yourself that question. Is this an element, a compound, or a mixture? You'll find the answers are often way more interesting than they first appear. Thanks for joining this explainer.